Hello students, welcome to my channel Learn at Home. In the previous lecture we had started chapter number 12, that is electricity. So in that chapter we had discussed some terms like electric current, potential difference, electric potential, current, and also Ohm's law. So according to Ohm's law, keeping the physical conditions same, so potential difference across the ends of the conductor is directly proportional to the current flowing through it, and V over I is equal to R is a constant quantity, and if we try to plot a graph between V and I, it will be a straight line. So keep this in mind that you are to take current along x-axis and potential difference along y-axis. So let us proceed with this R. R is a constant quantity and it is known as resistance or resistance of a conductor. So this resistance is constant. So resistance means the opposition offered by the conductor to flow of electric current. So R proportional to L, that means length of the conductor, means if more is the length, more is the resistance, so less will be current. So it will create a more obstruction for the passage of current, and also resistance inversely proportional to the area of cross section of a conductor. If we combine these two, so we get R proportional to L by A, or R is equal to rho into L by A, and where this rho is resistivity or specific resistance. And let us discuss about its units. SI unit of resistance is ohm, and let us derive about this units of this resistivity. This is equal to Ra upon length, and if we see, if we put resistance ohm and area is meter square, length is meter, that means resistivity has a unit ohm meter, right? So you see the factors, the main factor which affect the resistance, that is temperature, length and area. So that is why when during the transportation of electric current, so as the length is increased, so current, wastage of current is there. Why? Because resistance is more, and the wires through which current is passed, that are to be made thick, because more is the area, more is the current passing through this. Now, on what factor this resistivity depends? Resistivity depends upon the material, nature of the material, and temperature of the material, at what temperature, right? So according to this, we know the resistivity of silver is very much less as compared to the other, so that is why silver is best conductor of electricity, and aluminium and then copper are also conductors, but silver is the best conductor. Now resistance, how resistance are to be connected, or how combination of resistance can be made. So there are two combinations. One is resistance series combination, and second one is parallel combination. In case of series combination, let us take three resistances R1, R2, R3, and they are connected in series, and the common potential difference is to be applied, that is V, and V1 potential difference across the resistance R1, and V2 is the resistance, the potential difference through the resistance R2. Similarly, V3 passing through the resistance R3. Now V is equal to I into Rs, where Rs is the equivalent resistance or resistance in series, total resistance when they are connected in series. V1 is equal to I into R1, then V2 I into R2, and V3 I into R3. And as we know, V is equal to V1 plus V2 plus V3. So that means we are to put the values of V1, V2 and V3 here, and what we get, that is I into Rs, I into R1 plus I into R2 plus I into R3. So take I common from these three quantities and this I will be cancelled out. So what we are left with, Rs equal to R1 plus R2 plus R3, which is the required or equivalent resistance when they are connected in series. Now proceed with the parallel combination. Consider three resistances R1, R2, R3 connected in parallel like this circuit diagram, and this is battery and through which current I is flowing. At this point current is divided into three parts like I1, I2 and I3. I1 current passes through resistance R1, I2 through resistance R2 and similarly I3 passes through resistance R3, and they are meeting at point this, and ultimately again they give a sum of current I. So this is a circuit diagram for the parallel combination. So according to Ohm's law, as we know, V equal to IR. So here current is total current is equal to I. So we take I is equal to V over Rp, where Rp is the total resistance or equal resistance when they are connected in parallel. So I1 is equal to V upon R1, I2 is equal to V upon R2 and I3 is equal to V upon R3. So since I is equal to I1 plus I2 plus I3, so put down the values. I1 which is V over R1, I2 which is V over R2 and I3 which is V upon R3. So take V common from these three quantities and this is to be cancelled out with the left hand side, and what we are left with, 1 over Rp is equal to 1 over R1 plus 1 over R2 plus 1 over R3. This is the equivalent resistance when these resistances are connected in parallel. Now question arises, which combination is to be suggested for the wiring, whether it is this its combination, series combination or parallel combination. So we say that this is to be connected in parallel, because if one switch or one equipment or one device is out of work, then rest of the devices will work as such, and moreover the potential difference at every point will be the same. So let us discuss some devices. The first is battery eliminator. It is having a range of 2 to 12 volt. So these are two terminals, red is positive and black is negative. This is on off switch, and with the help of this we can click it to get a particular required voltage. So next one is we have this voltmeter. You see V is mentioned over here. So V stands for voltmeter and it measures the potential difference of the conductor. So it have so many scales, but in this case in between 0 to 1 we have 10 division, that means its least count is 0.1. So this is used to measure the potential difference, and no doubt it is having two terminals, positive as well as negative. Then next is we have ammeter. Ammeter means the device which is used to measure the electric current. So you can detect or you can guess which device is this. So here you see A is mentioned over there. A stands for ammeter, and it is also having a scale. And before using, students, any equipment we are to find least count, and in this case we have 10 division in between 0 and 1. So that means each division equal to 0.1. So next we have this plug key plug key means it is act as a switch, and now I have taken out plug. So that means if this is connected and plug, it is not being plugged, that means circuit is open, and as I put it like this, that means current will be flowing through the circuit. And next we have resistance. So resistance is like this is resistance coil and having different values, right? So by putting the different values, we can able to change the current. And next is having this variable resistance, or you can say like this is rheostat, and you see it is having a wires bonded on this, and it is having two terminals also like this, one terminal and this is second terminal. So always we are to connect this and this terminal in the circuit, and on sliding this we can vary the potential difference or current to the conductor. So last one I am going to show you Ammeter. Ammeter means you can measure with the help of this like potential difference and current, and also you can see the resistance of any conductor. So it is having, you see, different types of scales are there. This is ohm and AC voltage, DC voltage, and you see current, potential difference like this. So this is all about devices used during the making the connections. So that's all, students. This is all about the devices which we use during making the connections. So students, we will continue this chapter in the next video. So if you are new to this channel, just subscribe, like, share also, and till the next video comes, goodbye.